Hello and welcome. These are the notes for 3.4, Modeling with Quadratic Functions. If you have not done 3.3, you absolutely need that knowledge before doing 3.4. So in 3.3 is standard form of a quadratic function, and I talk about things about how to find the axis of symmetry and the vertex given standard form, and then how to graph. This 3.4 will be using all of those skills and applying them to word problems in real life situations. So there's no skills that are going to be new from after 3.3, but you do need the skills in 3.3 to be able to be successful in this section. There is a suggestion on there that you do need a multi-line scientific calculator, and we will be using it in this section. So, example 1, use a quadratic function to model the area of the rectangle. Graph the function. So to start off, we're looking for a quadratic function and we want to write that in standard form. You'll see my note up here, f of x equals ax squared plus bx plus c. That is standard form of a quadratic function. So my goal is to get the area written in that form. The area of a rectangle is base times height. Now, when I write that in function notation, I'm going to write f of x is equal to the base of this rectangle times the height. And my base here is 2x plus 6. My height is x plus 1. Now, you can multiply this using a couple different methods. I like to just take 2x and distribute it and then distribute the 6. Students are tending to lean towards using these boxes, and that's fine. That's a good learning tool. Eventually, we'd like to get you away from these boxes, but we can go ahead and use that for today. So the goal here is that I'm going to multiply what's above the box to what's at the left of the box. So 2x times x gives me 2x squared. 6 times x gives me a positive 6x. 2x times 1 is a 2x. And then 6 times 1 is a 6. Now, one thing I do like about the box is a lot of times your common and like terms are going to be on this diagonal here. So when I add these together, I get f of x equals, let's see, I've got the 2x squared, and then 6x plus 2x gives me the 8x, and then plus 6 at the end. So I've got this quadratic function, and that is the first part. Use a quadratic function to model the area of the rectangle. When they're saying that, use a quadratic function to model, they want you to write an equation. That's what that translates to. Write an equation for the area of the rectangle. So there's my equation. The second part of this is to graph the function. So just like we did in 3.3, we're going to use this tool, this little mini equation over here, x equals negative b over 2a, to find the x coordinate of the vertex, then plug it in to find y. So that's going to be my first part, is to find the vertex. So I plug in to find the vertex, and I'm going to make a little key here. A is the coefficient of x squared, b is the coefficient of x, c is the constant. And I get x equals negative 8 divided by 2 times a, which is 2, negative 8 over 4. So I get x equals negative 2. All right. The information that gives me is that tells me that that's where my axis of symmetry is. So I can just go ahead and add that to my graph. Then I'm going to take x equals negative 2 and I'm going to plug it in to my equation that I wrote myself, this one in the box, to find what is the output, right? What is the y value? And I wrote y here, but it would be more correct if I used f of x. Okay. So I'm going to take my function f of x, and instead of x, I'm going to write a negative 2. And using my order of operations, I'm going to go ahead and multiply this out. So my first step is the exponents. So you have 2 times this negative 2 squared. Negative 2 times negative 2 gives me a positive 4. I'm going to move over here. Then I do my multiplication. So 2 times 4 is 8. 8 times negative 2 is minus 12. And a plus 6 at the end. You should get that f of negative 2 is equal to negative 2. And that's a coincidence, the negatives there, the negative 2's. This can also be written as a point negative 2, comma, negative 2. So that is my vertex right here. Now, we've got some different ways where we can find other points to make a parabola. In 3.3, we focused on making a table. You can still make this table. Okay. I want to kind of point out, since we already did it this way, I want to point out some other things that you can do instead of just making a table and plugging in a bunch of values. So there's some great things that we can observe here. So let's go ahead and talk about that. One of the things we discussed in 3.3 is how to find the y-intercept. So the y-intercept is a point 0, c. Whatever my c is from this equation. So my c, I have the c value of 6 here. So I have a y-intercept of 0, 6. There, that point is on the parabola. If this point is on the parabola and I reflect it across the axis of symmetry, I get another point. Now I know it's this point because it's equidistant from the line. So this is 2 units over, this is 2 units over. Okay. Another way that we discussed how you could find a point on the parabola is really making this 2 as the leading coefficient work for me. So I have a equals 2. Well, when we have a vertex, all right, we talked about how we could find the next point by going over 1 and up whatever a is. So in this case, I have an a of 2. So I'm going to go over 1, up 2, over 1, up 2, and that'll give me the next point. Similarly, I go over the other way and up a, up 2. Now, if a was 3, I could do the same thing. If a is 1, I could do the same thing. Now, that doesn't give me a whole bunch of points. It only gives me that 1 point. If I were to continue over 1, up 2, over 1, up 2, I'd get a line. And this function is not a line. It's a parabola because it's a quadratic function. So I get this. All right. So the second part was to graph the function. There it is. The next idea is a vertical motion model. I've heard this more commonly called a projectile motion problem. If you hear one or the other, just know that they're the same thing. Vertical motion meaning I'm having something come up and then go back down, as opposed to side to side. When we talk about a projectile, we usually talk about something that's being thrown up or something that's dropping. So you can think of, for vertical motion problems or projectile motion problems, you can think of if there's a football on the ground and somebody's kicking it, how the path that that football travels is the shape of a parabola. You could also think of maybe if you are standing on top of a ladder and tossing water balloons up in the air and then watching them crash on the concrete. That would also create a parabolic shape, okay, or something the shape of a parabola. So we have this equation, h of t is equal to negative 16 t squared plus h initial times t plus v initial times t plus h initial. So let's break this down and talk about what all of these pieces are. This symbol, v with a little 0, this stands for the initial velocity. Before we even get into that, let's talk about what this little 0 represents. So this 2 right here, this exponent, is what's called a superscript. okay, because it's written a little bit above and smaller, right? So that takes the name of a superscript, and this is an operation. You'll see here and here I have a subscript. And this actually gives it's a way to name which one. It's a way to identify which V or which H I'm talking about. So it's not an operation. V of 0 means the initial vertical velocity. Okay, so you could think of that as the starting velocity. All right, or H of 0 is the initial height. You can think of initial as the starting. Okay, like at time 0. That's what that means. Speaking of velocity, it's important to point out that velocity is actually a little bit different than speed. So velocity includes direction. For our purposes here, we do use the proper term, which is velocity. They're very similar concepts, but they are not the same, so just be aware of that. It's not going to make a huge difference in this section whether we were to use the correct descriptive word, but to be precise, we always want to be as accurate as possible. This negative 16 that's in front of the t squared. Now, what that is when I have a large mass. Okay, let me try that again. I had someone pop in my room. Okay, so the Earth is a very large mass, and when we are talking about throwing small objects, it pulls at relatively the same rate. So negative 16 represents the rate of acceleration of an object to the Earth. So it is measured in feet per second squared. When we are close to the Earth's surface, we can round it to 16 feet per second squared. We use the negative because it's pulling something to the Earth, all right, which is what creates this upside down parabola. All right, so here we go. Example 2. A diver jumps off of a 30-foot tall platform at an initial velocity of 16 feet per second. Write the quadratic function modeled. So we are going to use this exact formula that's provided up here. H of t is equal to negative 16 t squared plus v initial times t plus h initial. And the problem gives me 2 pieces of information. A driver jumps off a 30-foot tall platform with a initial vertical velocity of 16 feet squared. I need to plug something in for v initial and something in for t initial. So which one's which? We're talking about a 30-foot tall platform. That means that this, at 30 feet, that's his initial height at time 0. Okay, so this is going to be my initial height. And then the velocity, what that means is that when this person leaves this springboard and shoots him or her or themselves up before they come down, they're leaving at an initial velocity of 16 feet per second. So I can just rewrite this with my V initial being 16 and my H initial being 30. That's it. That's my equation. Now the next part of the problem says, how high will the diver be at the highest point of the dive? Let's put this picture into some context here. So I'm going to draw on some axes. I've got a vertical axis and a horizontal axis. All right. And instead of x and y, these have different representations because my horizontal axis is time in seconds. And my vertical axis is height in feet, right? Which is represented by h of t, and this is represented by t. So my my y-intercept here is this point 030, right? Because I have the no time, and then I'm up here at 30 feet. And this person launches themselves, and I want to know what is the highest point. So what is this point here? Well, that highest point happens to be the vertex. So now all I need to do is I need to find the vertex. Well, we have an equation for that. X equals negative b over 2a. A is negative 16 because it's the coefficient of t squared. B is positive 16. C is 30. Now this equation, this formula has x equals, technically I'm finding t, which is just a different input. I'm just going to replace it and then plug in the opposite of b, and then divided by 2 times a, which is negative 16. Negative 16 on top. On the bottom, I have 2 times negative 16, which is negative 32. If you're more comfortable using a calculator here, you can. I have a bigger number on bottom, and this is going to give me t is equal to 1/2. Now, I like fractions. They make sense to me. They're easier for me to do in my head. We are going to move this fraction into a decimal, though, because that's how your online assignment is set up. That's what it asks for. So let's think about that. This vertex occurs when time is half a second. Okay, so my time is 0.5, and now I just need to find my height. Well, how can I find the y anytime I'm given an x? We're just going to plug it in. So my original equation is h of t, but I don't want to evaluate at t. I want to evaluate at 0.5. So everywhere there was a t, I'm going to replace with 0.5. Negative 16 times 0.5 squared plus 16 times 0.5 plus 30. And I use my order of operations to simplify the entire right-hand side. When I work through my order of operations, I get 34. All right, so what does that mean? That means the point is 0.5 comma 34, and 34 stands for height. So my answer for what is the highest, how high will the diver be at the highest point of the dive, is 34 feet. For your online homework, when it asks you these questions, it's going to give you an empty box for you to put the numerical value of the height. And then it's going to have a drop-down menu where it's going to ask you, is this feet? Is this feet per second? Is this feet per second squared? Tell me about it. Okay, so make sure you choose the appropriate units. The examples in 3 are really the same thing as example 2. There just provides more practice, and it is examples that don't have a story connected to it, but it's going to be the same work. So I'm going to do the part that I did in blue. I'm going to write the equation. Then I'm going to do the part that I did in red, and I'm going to find the vertex. Therefore, I can find the height. So my plan is the same. Example 3, write a quadratic function to model the vertical motion of each situation. That's the equation part. Part 2, find the maximum height. So for A, I have an initial vertical velocity of 32 feet squared. Initial vertical velocity. I have an initial height of 75 feet. So I'm going to go ahead and plug those in. H of t equals negative 16 times t squared plus V initial is 32. H initial is 75. Now, sometimes I get the question, students ask, well, where did the negative 16 come from? It's part of the original formula. So we're plugging it in already because we're assuming that all of these problems are going to happen close to the Earth's surface. So we have a constant rate of acceleration. All right, so that's part of the question. That'll be part 1 in your online homework. Part 2 is to find the maximum height. So I plug in x equals negative b over 2a, where a is negative 16, b is 32, c is 75. So on top, I'll plug in a negative 32. And on bottom, I have divided by 2 times negative 16. And we get a time of 1 second. So that's the time where the maximum height occurs. It's the time, the first coordinate of the vertex, but I need to find the height. So to find the height, I now plug 1 into my original problem, the original equation that I wrote. So instead of t, I'm going to replace it with a 1. And then use order of operations. First thing I have to do is square the 1. So 1 squared, that's just 1 times 1, which is 1. Negative 16 times 1 is negative 16. 32 times 1 is 32, plus a 75. Negative 16 plus 32 plus 75 is 91. So h of 1 equals 91. You could also write this as a coordinate. The piece of information we're looking for is find the maximum height. So my height is going to be 91 feet. Problem B. Now, again, this is the same exact type of problem as A. What we're going to see different here is that I'm going to get some decimal answers that are not going to work out as nicely. So I wanted to go over an example with you here because you could very well have a similar problem in your homework, and I don't want you to be deterred by the long decimal answers. So we go again. I write my equation. Let's see. Initial vertical velocity, that's going to be v initial. Initial height, that's 8 initial. H initial. Negative 16 t squared plus 50 t plus 5. All right, there's my equation. And when you do enter these into your online homework, make sure you are using t instead of x. Now, I'm going to go through and identify my a, b, and c and plug them in to find my axis of symmetry, which gives me the independent coordinate of my vertex. Negative 50 divided by 2 times a. So I have negative 50 divided by negative 32. And when I plug that in, this is definitely where you want your calculator, I get 1.5625. No, you cannot round that. You need to use all the decimal places and be very specific and careful about leaving all the decimals there. All right, now the next step is to plug that in to h of t. So h of 1.5625 is equal to negative 16 times t, which is 1.5625 quantity squared, plus 50 times 1.5625 plus 5. So I've replaced all of my t's with my value, with my number of seconds to reach the vertex. Okay, order of operations. Now, I suggest when you plug in 1.5625 squared into your calculator, leave it there, all right, because this is going to get worse before it gets better. 1.5625 squared is 2.44140,625. Yes, write it all out. Now, you already have this long decimal in your calculator. Take that and just hit times -16. Just multiply by -16. Don't retype it. It gives you too many opportunity for error every time you have to retype one of these decimals. So I multiply by -16, I get -39.0625. Then I'll have to do 50 plus 1.5625. Or 50 times, I'm sorry, I misspoke, 50 times 1.5625. And that's 78.125. And when I add all of that up using a handy dandy calculator, I get 44.0625. All right, so what is my maximum height? It's 44.0625, and you'll enter the entire answer like that into the answer box. So the assignment does ask for you to answer in either decimal or integers. So it does not ask you to do any rounding. So we're gonna have that exact answer in there. All right, thank you very much for tuning in, and I hope that you are well. Take care. Bye-bye.